Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Pythagorean Identity, and Double Angle Formula. Question 4. The sine of x is equivalent to 1 over 2 and the sine of 2x. To inquire about purchasing this complete Cram session, inbox me at memedicine@gmail.com for pricing, and also inquire about other subject areas. Let's delve into the problem. Good luck studying. Review question 4. If x is a positive acute angle and the sine of x is 1/2 or 1 over 2, what is the sine of 2x? Is it 1, negative 1/2, 2, 1/2, 3, negative radical 3 over 2, or 4, radical 3 over 2? So I'll give you a moment to formulate your answer and come up with a great solution, okay? Definitely press pause. All right, so hopefully by now you've come up with a solution, and if not, that's totally fine. Let's try this out together. So the general formula for the sine of a double angle is going to be the sine of the double angle, or 2a, is equivalent to the sine of a times the cosine of theta. So it's equivalent again to 2, I think I said this wrong before, 2 times the sine of a times the cosine of theta. Okay? All right. So this is what we're going to work with a little later on, but now let's take a look at the information that we're given. Let's diagram it. So in order to find the cosine of x, which we need for the double angle formula, we're going to label the triangle with the values that we got from the sine ratio, okay? And what you have to remember is that the sine of theta, or in this case, x, for our circumstances, is going to be the y-coordinate over the absolute value of the measurement of the ray that the line makes with the axis to form the particular angle, okay, or the respective angle. And you also have to note that the cosine of theta, but in our case, our theta is x. It's just that, you know, this is labeled x for the x-coordinate as well. So the cosine of theta is going to be the value of the x-coordinate divided by the absolute value of the measurement of the ray that intersects the coordinate system at 0 to form our positive acute angle, okay? So what we're now going to do is basically label, again, with the information that we're given in our sine ratio. And since we just found out that the sine of theta, x, whatever you call the angle, whatever variable you assign it, is going to be the y-coordinate over the measurement of the ray. So here, 1 corresponds with our y-coordinate, and the 2 corresponds with the absolute value of the measurement of our ray. Okay? All right. So you guessed it, in order to find the missing side A, we're going to have to use the Pythagorean theorem, which states that a squared plus b squared is equivalent to c squared. All right, so let's plug in our known information. We know like a b, and we know c, or the hypotenuse. Okay, so a squared plus 1 squared equals 2 squared. Now we evaluate the exponents, and we get a squared plus 1 is equivalent to 4. Now we combine the numbers, so we have to subtract 1 on the left-hand side to bring it over and subtract it on the right-hand side as well. So we wind up with a squared is equivalent to 3. Now when we take the square root of both sides to sequester a, we get that the measurement of a is equivalent to radical 3. Okay, so take a breath. Hopefully you're keeping up with what's going on. And so from the diagram, because we know that the cosine of theta, or whatever angle we're interested in, is going to be the value of the x-coordinate over r. So our x-coordinate here is radical 3, and our r is 2. So therefore, the cosine of x is equivalent to radical 3 over 2. Okay, so now we can go back and input this information into our double angle formula, because remember, the double angle formula says that the sine of 2a is equivalent to 2 times the sine of a times the cosine of a. Well, we figured out our cosine, we're given our sine, now let's solve. The sine of 2x is equivalent to 2 times 1/2, remember that's our sine, times the cosine of x, which is radical 3 over 2. That's what we just figured out. And this works out pretty neatly because the 2 here cancels with the 2 in the denominator. And so we have it that our sine of 2x is also equivalent to radical 3 over 2. So the correct answer choice is answer choice 4, okay? And let's talk about some time savers. You could have saved time on this problem, or I'm sure a lot of you did, if you recognize the value for the sine of 30 degrees. You should know for a lot of the general angles, when I say general angles, I mean measurements like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and the quadrantal angles, when I say quadrantal, I mean 90 degrees, 180 degrees, 270 degrees. You should know all their sine, cosine, and tangent values so that you can save time, okay? So if you had known the sine of 30 was 1/2, you could have figured out the sine of 2 times 30 degrees, which would be the sine of 60 degrees, okay? And you should have also known or memorized the value for the sine of 60 degrees. And so, in addition, another third way to save time is to use your, that's right, you guessed it, your handy dandy graphing calculator. The series of calculators I'm going to be referring to in this particular illustration is the TI-84, TI-83, the TI series, okay? And if you have a Casio or some other brand of graphing calculator, the concept will definitely be the same, so don't stop, keep on watching, okay? So you could have saved time solving this problem because we're told that the angle of interest, x, is basically a positive acute angle, okay? And when the angle is positive and acute, using your graphing calculator is an accurate and easy approach because the angle obviously is going to occur in quadrant 1, okay? Quadrant 1 is bounded by 0 degrees and 90 degrees. Using your calculator is not difficult, but if it's a little trickier if the angle is greater than 90 degrees or beyond quadrant 1, okay? So let's check out how we would go about using our calculator. So first, on your graphing calculator, you're going to turn it on, obviously, and then you're going to hit mode, okay? And when you hit mode, this screen comes up, all right? And so the cursor will be flickering over normal. What you're going to do is press the down arrow once so that the cursor is flickering over float, and you're going to press the down arrow a second time so that the cursor is now blinking over radians. And let's just pretend that instead of degrees, radians is highlighted. What you're going to do is hit the right arrow so that the cursor can be flickering over degrees. You don't need to press enter to lock it into degree mode because now you have just set your calculator to degree mode. All you need to do now is press second mode to quit the screen, okay? And you'll be back at the home screen for inputting numbers and equations, okay? All right, the next thing that we're going to do is basically input the inverse sine, okay? An inverse sine is used to figure out what angle this trigonometric value belongs to. So anytime you see an inverse sine, inverse cosine, inverse tangent, inverse anything, you're going to get an angle for an answer, okay? You're not getting a trigonometric value, okay? So you input the inverse sine by pressing second sine, and it comes preloaded with an open parentheses, and then we have 1/2, so we're going to type 1, divided by, which is going to represent the fraction bar, 2. And then we close out our parentheses and hit enter, and then we get an answer of 30 degrees, okay? Because remember, we're in degree mode. Then the next thing that you're going to do is solve for the sine of 2x, okay? So to do that, you press sine, it comes preloaded with an open parentheses. You're going to press the number 2, and then you're going to recall the last answer that you got, which was x. So you can do that by pressing second and the negative sign. The negative should be located at the lower right-hand corner of your calculator. And what these two keys do together, it recalls the previous answer. So now what you want to do is close out the parentheses and hit enter. And that basically gives you the sine of 2 times 30, or the sine of 60 degrees, okay? And let's say, okay, you're given, the answer that you yielded is a decimal answer, but you're given fraction answers. Well, you can do process of elimination initially, because the answer isn't negative, so you can get rid of those. And the answer is not 1/2, because most people know that 1/2 represented as a decimal is 0.5. So therefore, the answer has to be this, okay? Radical 3/2. So what you can do now is plug and chug the square root of 3 divided by 2 into your calculator, and it's going to match up, okay? And what you do for that is you're going to hit basically second, and then you're going to hit the x squared button, and that's going to pull up the square root sign. It comes preloaded with open parentheses. You hit the close parentheses button, this one right here, and then you hit your division sign to represent the fraction bar, and 2. And you're going to get the same answer as you did for the sine of 2x, or the sine of 60 degrees. All right, thank you for your time, and hope to see you in the next round, okay? All right.